Hello and welcome to another video. This video is centered around taking the derivative of the inverse of a function at a given point. Now there's so many things locked together in this concept, and there's one I want to clarify first. Before that, please make sure you hit the like button and you're subscribed if you're not. If this is the first time watching my videos, or if you've watched my videos more than once, there's a good reason for you to subscribe. Okay, thank you. A good comment under the video will make YouTube want to recommend the video to somebody else who might need it. You may not need it, but you might be saving a life. Okay, make sure you remember to like the video. Now let me quickly explain the concept. See, you've heard the term reciprocal, you've heard the term inverse. Both of them are not the same, and I remember my elementary school teacher taught me that the inverse of 2 is 1/2, but that's not correct. That's the multiplicative inverse of 2. What about the additive inverse of 2? It's going to be -2, and that was not clarified when I was growing up as a little child. But now I'm a grown up and I know what the difference between the two. Okay, so let me clarify something so you don't get stuck in trying to escape the rigor of your calculus work, and then you think that the inverse is the same thing as a reciprocal. They're not. So let's say you have f of x equals 2x. Well, if you make a table quickly, if you have x as the input and the output should be 2x, that's the function. If you have 1, 2, 3, your output should be 2, 4, 6. Okay, that's your output. However, when we're talking about the inverse of a function, we're just saying that if you look at this function, the inverse of this function will reverse the operation such that what was your output becomes your input. So here I'm going to use the numbers 2, 4, and 6, and on the outside, so my x becomes, what was the output here becomes the input, and I'm expected to get my output to be the same thing as the input of the original function. So what would I do to 2 so that I can get 1, 2, 3? What am I doing? Well, obviously, I am dividing x by 2. So the inverse function of x, so you can say if f of x is 2x, then the inverse function of f, okay, is x over 2. How would you know? What if it's more complicated? What if you don't have numbers? It's just easy. Let me show you. So let's say you're given f of x to be, let's take this 2x. What I want you to do is replace the f of x with y. Just replace it with y. Just say y equals 2x. Then I want you to isolate the x. Why? Because right now, we're told that y is always the output and x is the input, the independent variable. So that's why we usually write our coordinates plane as input, then output. That's what we usually write. So that here, this is your input, this is your output. Input, output, input, output. So you have these points here. 1, 2, you have 2, 4. Input, output. But when you get to this point, you notice that we've reversed it such that what was our output has become our input. So that's what you're trying to do. You're trying to make sure that x is now your output. So if we try to isolate x, we're going to get x equals y over 2. When the old input becomes the output now, you have established what you call the inverse of the original function. So we can write this, instead of writing it this way, we don't want y showing up. Okay, we're just going to say the inverse function of x is now x over 2. So you see how I just changed the notation. It's the same thing. The function works on the input. Remember, the input is the independent variable. Here, the input is now what used to be our output, which was the y, but now it's now behaving as if it's x, and that's what you've got. Okay, now can you differentiate this function? Yes. What's the derivative of 1/2 of x? Your answer is 1/2. Okay. Now, the reason I'm going to do this video and explain the things I'm about to explain with these examples is because sometimes you cannot find the inverse function. You see how easily I was able to do the algebra and I isolated x? Tell me how you're going to isolate x here. Well, you have to use the cubic formula. You have to get many x's, okay? And that doesn't work out. Tell me how you're going to isolate x here. It's impossible because x is the argument of this tangent function. You can't even isolate it. So, because there are times you cannot, most of the time you cannot isolate this, you need to understand this topic and the formula that you're going to see in this video. In another video, I'm going to show you the proof, but I don't want to make this video too long. So let's get into how to solve this. So as you can see, this is the inverse function of this function. Now there's a third thing people confuse, and it's called the reciprocal. Well, the reciprocal is just 1 over f of x. Well, 1 over f of x is not the same thing as this. They're two completely different things, because when you have this, what you got is you have x, and you have on the table 1 over, what is f of x? F of x is 2x. Okay, so when your input is 1, 2, 3, well, 1 over 2 times 1 is 1/2, rather. And 1 over 2 times 2 is 1/4, and this is 1/6. So as you can see, these numbers don't even look like what we've been dealing with, and this is not the same thing as this. So the inverse function of a function, or the inverse of a function, is not the reciprocal of the function, because this is the reciprocal, this is the inverse. The inverse takes the output and makes it the input, runs it through the machine, and generates the old input as the new output. You see? The old input becomes the output, because the output from the old machine became the input for the inverse machine. I love the machines. Now let's solve these problems, and I'll show you what to do. Okay, let's go. Remember to like this video if you like it. You should like it. Let's go. So if you look at this, you would notice that there's something weird about why did we put this here? Well, this is the reason. Let's look at the graph of f of x equals x squared. It's a parabola. It's the toolkit function, or what you call the parent function for all parabolas. And this is what you're going to get. You're going to get something that looks like this. Well, look at this function. This function does not pass the horizontal line test, which means it cannot have an inverse function. Okay? A function has to be 1 to 1. 1 to 1 means every input must have only one output, which this one passes because it passes the vertical line test. And every output must have only one input, which is not true because look at this point. Point 1 is generated by the point 1 and the point -1. If you input -1 in here, you're going to get 1 as your output. If you input +1, you're going to get 1 as your output. So because this function as it is cannot have an inverse because it fails the horizontal line test, which means it is not a one-to-one function, we have to restrict the domain to only one arm. So what we're going to do is delete this part. See, the word delete did not exist until computers showed up. But now we say it as if it has always been from the beginning. Who knew the word delete? But let's delete. So now that we've deleted one arm, this is a one-to-one function. It passes both the vertical and the horizontal line test, and now we can use it, and that's the reason why we have this. Remember, we're dealing with inverse functions. So only a one-to-one function can have an inverse. Okay, now that we understand that, I'm going to show you the two ways. One way, because the first way, just the way I did the other example I did, and the second way will be the new way, which is the best way. So the first thing I'm going to do is find the inverse function and differentiate that function and plug in 9 in the function, and then I'll get my answer. So let's go. Well, we're going to say let y be equal to x squared. Okay? But we want to isolate the input. See, this was the input. We want it to become the output. So we're going to say x is equal to the square root of y. Okay, you might say, why didn't you say plus or minus? Well, I don't want to say plus or minus because we're restricting the domain of all inputs. You see, now y has become the new input. And every time you talk about the inputs, you want to stick to the positive inputs. So that's why I'm not going to do plus or minus. Okay? So this is okay. Remember, we've deleted the minus part of the graph. Okay, so at this point, x equals the square root of y, and we can say now that the inverse function of x is equal to the square root of x. This is the inverse function. Okay, so do I know how to take the derivative of this inverse function? Yes, because I can say that f prime of x, we take the derivative, let's put it this way, the derivative of this will be equal to the derivative, which would be d dx. Let me write it that way. It would be the d dx of the square root of x, which is x to the 1/2. To differentiate this, it's going to be the 1/2 comes down, and then you have x to the -1/2, which is equal to 1 over 2 square root of x. Okay, now let's evaluate this when x is equal to that a, which is 9. So we're going to say, let's just do it here. We're going to say that this evaluated, f prime of the inverse function evaluated at 9 will be equal to 1 times 2, 1 over 2 times square root of 9, which is equal to 1 over 2 times 3, which is equal to 1 over 6. So as you can see, our answer is 1 over 6. We were able to do this because we know how to find the inverse function. Okay, when you cannot find the inverse function, this is what you must do. Let's see it. Now that you cannot find the inverse function, let's assume we know we could for this one, but let's just say we couldn't. What should you do? Let me tell you the first thing to do. You have to know this formula. Know. The key word is know. And it is defined as, if you have the inverse function and you're supposed to take the derivative of the inverse of this function at a point A, your answer is going to be so simple that all you have to do is write this, look at the derivative of this function itself, and evaluate this function at the inverse at A. Okay, so the first time I saw this formula, I was so confused that I didn't use it because I didn't understand what all this means. Now, when I use this example, you will understand it clearly. So let's go to the beginning. Okay, so this is the formula. I'm saying what you're looking for. Don't worry about looking for the inverse of the function. Don't, because you can't. For example, you can't for this, you can't for this, but there's a way. Look at the function you're given. F of x equals x squared. What is the derivative? What is f prime? Tell me, what is f prime? F prime of x is 2x. That's all you need. This is all you need. Okay? Once you know this, the next thing is to start thinking. Remember that you're supposed to evaluate the inverse function at 9. What does inverse function do? Remember, the inverse function takes the old output and makes it the new input. So ask yourself, if this is the old output, what input did I use so that I would get a 9? If you forgot, just make a table, quickly. Make a table. This is x, this is f of x. I know my output will be 9 because that's what I'm going to feed into this function. That's my a. What would I put here so that when I put it in this function, x squared, I'm going to get 9? Well, it's going to be 3, not negative 3. Remember, we restricted the domain to all positives, so don't think of negative 3. You have one option. Now, my old input, my old output. Okay, so once you know that what your old input is, okay, will give you your old output, all you have to do is tell yourself, okay, now I know what this will be. Because remember, if you put 9 in the reverse function, what will be your answer? Your answer is going to be 3. That's it. So you know now that when you make a new table, and this is f inverse of x, and this is x, this is going to be 9, and what comes out of this is going to be 3. So this value here is going to be 3. And this value here, that is 3, is what you're feeding into the derivative that you already found. You just need to put 3 here. So this part of the problem just tells you, ask yourself, what will be the input so that this thing here that they're giving me will be the output? And that's what you need to feed into your formula. You don't need to evaluate this. Nobody wants you to evaluate this. You'll just be the one to figure out what that number is. Okay, so let's solve this properly. Okay, so what you want to do as part of the calculation is to say that f of 3 is going to be 3 squared, which is going to be 9. How did you get 3? Well, you're supposed to just figure it out. So that's the thing. You have to just, you try numbers, okay? You try numbers by investigation. That's what it's called. You have to investigate what number you're going to plug in so you can get 9, okay? Now that you found this, okay, you can now say that if you plugged in 9, you're going to get 3, which is what's supposed to be here. So let's go. So go here and say, therefore, the derivative at 9 will be equal to 1 over f prime of x, but x is evaluated at this, which is 1 over, what is f prime of x? It's 2x. You see that? Because if you put 3 here, you're going to get 6. And that's it. Your answer is 1 over 6. So I've shown you that you could actually find the inverse function, take the derivative, or you can just use common sense. Let's apply some common sense to this one. Okay, so this one is a polynomial. We didn't have to restrict the domain. Let's just go into it. The first thing you want to ask yourself is, firstly, what is f prime of x? What is f prime of x? Always remember that. You take the derivative of this, what are you going to get? You're going to get 15x squared, and this is going to be plus 6x minus 1. That's what you're going to get. And based on the formula, what you're looking for is actually, let's leave that for now. Okay, we'll have the formula down here at the end. But so you've gotten this. You'll need this one for the formula at the end. But right now, you want to look for what number you will plug into this function so that you'll get 0. Now, this is something I would recommend. Every time, always start from 0. So look at the number line. I want you to start from 0. If 0 doesn't work, go try 1. If 1 doesn't work, go try negative 1. Unless you can clearly see it. So let's start with 0. If I plug in 0 here, everything that contains x is going to turn to 0. So this is 0, 0, 0, plus 1. No, we want 0. Okay, let's try positive 1. This is going to be 5 plus 3 minus 1 plus 1. No, that's 8. But we want 0. Let's try negative 1. This is going to give you 5 times negative 1 cubed. This is going to give you plus 3 times negative 1 squared minus negative 1 plus 1. So this gives us negative 5. This gives us 3. This gives us plus 1. This gives us plus 1. So it's negative 5 plus 5. That gives us a 0. So for you to get a 0, you need to plug in negative 1. Let's do it. So your next line after your investigation should be that f of negative 1 will be equal to, you can now show your answer, your work, just say 5 into negative 1 cubed plus 3 into negative 1 squared minus negative 1 plus 1. And your answer is going to be f of negative 1 equals 0, which means that the f inverse, or the inverse function of 0 is going to be negative 1, which is the major part of your formula. Okay? So the f inverse of this is going to be negative 1. So it's this negative 1 then that you need to plug into this function in the formula. So this is it. F inverse, the derivative at the point, what's the point? At the point 0, okay, will be equal to 1 over f prime of, what would be the value of this? Negative 1. Okay? Which is the same thing as 1 over, what is the derivative of f? It's 15x squared plus 6x minus 1. That's going to be 15. What is x? Negative 1 squared plus 6x plus 6 times negative 1 minus 1. Well, let's bring it down here. That tells us that our answer is 1 over, this is going to be 15, and this is going to be minus 6, and that's minus 1. So that's 1 over 15 minus 7 is 8. And that's how you solve this. So you see that the most difficult part of this is for you to just investigate what you'll need to plug in to get this. That number you need to plug in is what you go plug in here, and you just take the reciprocal of this, and that's your answer. It's so easy. Let's get to the last question, which is this one. So you want to start thinking, you see why we're restricted the domain here too? It's because of this guy, okay? This guy is undefined at certain points. If you get to this point, there will be no value. If you plug in negative 1 here, you're going to have negative pi over 2, and tangent is not defined at that point. So that's why we try to avoid those points, and that's why we have this restricted domain. But again, we're good. Let's just start thinking of what number we're going to plug in here so that what is left is going to be 4. And I can see that, you can see that it's going to be 0. Because if you put 0 here, tan 0 is 0. If you put 0 here, this becomes 0, and what's left is just 4. So like I said, the examples are usually very easy for you to guess. You just need to remember that this is the formula you need to use. So for the final example, this is what we have. And like I said, by observation, what would you plug in here so you get 4? Well, the 4 is obviously standing here. So you're thinking of a number you plug in here that will take care of all of these, like remove them. So a 0 will work here, a 0 will work here. Because if you plug in 0 here, this argument gives you 0, and tangent of 0 is 0. Here, this becomes 0. So you can just go straight to the point, because you just say, by investigation, like the FBI, by investigation, I know that if I plug in 0, I'm going to get 4. That means if I plug in 4 into the inverse function, I'm going to get 0. This is the long and short of all we've been saying. Now, what's the work you need to do? Well, it's important that you get the derivative of this function. That's the most difficult part of your work. Remember, the formula tells us that if you take the derivative of this at a, your answer should be 1 over the derivative of the original function if you evaluate it at this value, which is going to be 0. But we're going to write it straight like this at a. Well, we know that the number that's going to be here is the 0, because we've already done the calculation for this. So this is going to be equal to 1 over this function evaluated at 0, f prime of 0. Well, we just need to know the function. If we take the derivative of this, what will we get? Well, let's quickly do that. What is f prime of x? It's going to be 0 plus 2x plus, what is the derivative of tangent? Secant squared. That's something you need to remember. So the derivative of tangent is secant squared. But this is a composite function, so we have to multiply by the derivative of what's inside, which is pi over 2. So secant squared pi x over 2 multiplied by pi over 2. Well, I could bring the pi over 2 to the side, but that's not super important. So let's evaluate f prime. See, we have this. We just want to get our answer. Okay, we want to get our answer. I'm going to go plug in the answer here once we're done, because all we need is to know what this will be when that is 0. So let's go. So this is going to be equal to, so what is f prime of 0? What it's going to be, we just need to plug in 0 here. You don't need to simplify. This is going to be 0 plus 2 times 0 is going to be 0 plus secant squared. This is going to be 0 multiplied by pi over 2. What is secant squared 0? That's 1 over cosine squared 0. Well, cosine 0 is 1. So 1 over 1 is 1, okay? So this is going to be equal to 0 plus 0 plus, this is going to be 1 times pi over 2, which is pi over 2. That's all you get because this is going to give you 1, okay? And this is pi over 2. So I'm going here now to replace this. It's going to be 1 over pi over 2, which is 2 over pi. If you learned something in this video, make sure you leave a positive comment, okay? Be subscribed if you're not. And remember, those who stop learning have stopped living, so never stop learning. Bye-bye.